There's me, I'm architect at OSGi, and there's my colleague Todor Boev, who's also senior engineer and architect. He's not able to be here. He's actually the co-chair of the Enterprise Expert Group at the OSGi Alliance. So this talk is about breaking software, how to better break software. So it's about breaking changes. I'm sure you all know about breaking changes and how they affect you and how to deal with them. So I'm going to skip the abstract. So I'm going to give you some motivation and why we think this is important and worth talking about. I'll look at an example of code evolution. We'll present our proposed convention for handling breaking changes, especially as regards to versioning, and some reasoning behind it. And then we'll show the revised example which applies the convention, and then discuss some findings. If we have time, I could also show some concrete code. So what we found over the years that we, even as OSGi Alliance, who apply the concept of semantic versioning, have found ourselves not able to actually make breaking changes using semantic versioning. So there were extensive discussions, should we introduce a new version of the OSGi framework and upgrade the OSGi framework package. There were, as you know, an API which has developed over now 2 decades. Will show some signs of age, and there will be always reasons to try to update to become more up-to-date and so on. So one example that was discussed was that the dictionary API still appears in some APIs. So could there be just an update of the whole package, the whole API, which brings everything up to date using the most modern pieces of Java that are available, and just bump it up to the version 2.0? Like semantic versioning suggests that you do, and then move forward. And all the discussion showed that there's not really a good way to actually bring the community with you. So how do existing users move along? How do they move to this new universe? So it turns out that there's never been this kind of a breaking change in any published API. There was one example of the device management tree API where, in fact, there was a breaking change, but then in that process there was even, again, a new package introduced. So in that sense, it was not a breaking change in the sense of semantic versioning. And that was so long ago, I think I had even difficulty identifying where I would find that old spec. And if you look at in other places beyond OSGi, you'll also see that breaking changes are in JDK, which is also a very large body of APIs where there is a big consumer base, of course. Breaking changes are not done within published packages, but then there will be something new introduced side by side. So you introduce Java NIO files instead of trying to update Java IO file to provide the new functionality. Or Log4j in version 2, they introduced a new package. So what is behind all this difficulty? So if we look at a typical example where you have some kind of a utility package going through the steps of a typical evolution, so you start with some package 1.0, then you proceed to a version 1.1, you have introduce some additional backward compatible changes, 1.2, then at some point you say, okay, I've got some real new stuff that I want to add to this utility package, and they're going to break my consumers, so I'll just follow the rules of semantic versioning. It's as simple as that. I just bump up the major version number, as semantic versioning suggests. So you bump it up to version 2.0. So this is the breaking change that you're having. And there are consumers, so you have one slowly evolving consumer that we call slow. It's importing one of the versions of this ORG-util package. It was built against this one originally. Here it says it can deal with anything from version 1.0 up to not including version 2, so definitely it will not be able to use these utility package, not semantically, but not because it can't cope with the functionality in there, but simply because the version says this is a breaking change, so that's it. Whereas we have this fast consumer. The fast consumer is also built originally against one of these versions of ORG-util, 1.1 in this case, and it claims that it will be compatible with any 1.x version of ORG-util, but it also uses ORG-slow. So it also has, wants to use this other provider, which is slowly evolving. And now, at some point, you have this, the fast evolving consumer wants to use the new stuff in ORG-util 2.0, but it's still using ORG-slow, which hasn't evolved. So when you try to set up a build or deploy a system that actually works, you find that you can only choose from these these builds of the different packages of the different modules to provide to get a system that actually works. And when you try to get a working version of fast 1.2, then it breaks. And there's no way you can, nothing fast 1.2 can do. The only thing fast 1.2 can do is wait for slow to upgrade or build their own version of ORG-util that will help them and provide and leave ORG-util 1 in the system for slow. But still there will be, can be possible conflicts here. So what's behind this? Behind this is are sort of the human expectations of how code evolution is supposed to work. And one message of around semantic versioning was that, well, use semantic versioning to declare when how changes are compatible or not compatible, and then you'll be good. So people use semantic versioning and think, yeah, that will solve these issues around software evolution. So they're introducing this relative stepping of the different modules, so you can kind of view this as relativistic time. So you have fast moving time here, you have slow moving time here, and you have also quite fast moving time here, and you express that through the version number, so you think you're okay. And you are used to the fact that when change is introduced, it's by accretion, which means you're simply adding stuff to what you already have. So you're not throwing anything away, you're simply adding stuff. And you're not replacing things. You think, well, everything that was once built, look at Maven Central, will still be available for all time to use. And well, why doesn't my system, like the sophisticated OSGi resolver, go and simply construct my running system? Because that's what all this versioning is supposed to do. You're expressing your requirements. You're publishing the fact that changes are breaking or non-breaking, that they're backward compatible or not. So the these modular systems should somehow be able to cope. And then, because I'm expressing my incompatibility, like I'm creating the new version of my util package 2.0, publishing it to the world, telling everyone, yes, this is still util, but it's the new version, so perfect, you can use it, feel free to use it, but just realize it's a breaking change, so everything should be good, everyone is following the rules. But actually that's just not the case. So the main failure here is in the human expectation that a breaking change can happen while you're violating the accretion. We'll look at that in a minute. And another human expectation probably is that is a problem here is that when you're upgrading your stuff, you want your stuff to be clean, so you're the provider of the util 2.0, and you think this is a great new version of my package, and the code is good, and I've marked it out as the best new stuff, then everyone should upgrade in their own interest, because everyone wants to work with the best new clean code. But that's a failing expectation. It simply doesn't happen. Simply a fact that systems don't evolve that way. So the meaning of the breaking change is actually that the meaning of the name changes. So your util package provides things, and they are used by name in your code, and the breaking change is that actually the meaning of the names change in a way that that is beyond the understanding of the current consumer. So you have to change your understanding to be able to cope, to follow. And the modular system can't really help you with this, because because this principle of accretion, this simply adding stuff, is being violated, in fact. So the breaking change, it doesn't replace the old versions of OSGi, because they are still there. I mean, you can still probably pull them from Maven Central if they've been put there, but they have been, the meaning of util has been changed. So there has been a replacement. It's not just accretion. So that's, I think, one of the core insights around this, so that the difference between accretion and replacement, so that you're not simply adding stuff for everyone to just pick from, but you're actually changing things without being kind of honest about it. So you are saying, well, it is a breaking change, but you have taken away the old meanings of the name, in effect. And this is because your code is binding to these names and to the meaning of the names in all sorts of places, and it's in places that you don't have under your control. So in this case, the fast module doesn't have the slow module under their control. And the language can't really help you, because you can't expose one compilation unit to the different meanings of the same name. So this is just how code works, at least in sort of the common languages we use. So we don't really import an identifier from somewhere as something else to have name distinction in the code. Possibly some kind of approach like that could help, but it's just simply not the case in the coding systems we use. And the modular systems are responsible for composing this consistent namespace. So for each module, they're supposed to fish out the compatible available components to assemble into a running system. And they simply fail, but not because the modular systems are bad, but simply because it's impossible. So it's not an OSGi problem. So OSGi is not at fault here. OSGi is, in fact, helps you in a way because of these users constraints and the way the resolver works and the way this isolation works. You will find these errors early. So it helps you identify these places where you have conflict, but it can't fix the fundamental issue. And I'm sure that all of you in some way or the other have experienced this and really gotten to hate these kind of constraint violation errors that appear when you try to assemble your code. So what's the solution to this that we propose is simply to make sure that you properly use accretion, so that you properly introduce new names when you have breaking changes, and then it will no longer be breaking because you're not taking away the old meaning of the name. Because if you, the compiler will make sure that you separate the names properly. It will force you to use the correct names in the correct places. And for this, we propose this way of using the version numbers and this way of applying semantic versioning. So there is this period where you start with a major version number 0. That's this prototype period. That's completely in line with semantic versioning. So in that at that stage, there is no guarantee for compatibility. So breaking changes can occur at any time, and that's intended. That's part of the game here. One thing that's perhaps of interest is that at least the package name is reserved. So the example foo in this case, that would be reserved at this point. So if I'm introducing org-util, the package with a version number of 0, then at least sort of in the world that uses this package name with the version number 0, the package name is already reserved, although it hasn't reached its stable definition yet. And in this stage, breakage is allowed. Then the second step is when we actually jump to version 1.0, and that's where both the package name becomes locked down because we've released an official version, and the contract of the name becomes locked down as well. So the meaning of all the names I introduce. And then I can move forward with that in that major version 1, so I can make changes that are compatible, so completely compatible, which is the I update the patch number, or I can update the minor version if I'm adding things that are relevant for a provider of an API, but not relevant for the consumer, or don't break the consumer. It's additional functionality. So I'm enriching the contract in the sense that more things are possible, but I'm not breaking anything that's already been asserted. And then comes the controversial next step, because semantic version would say that if you have an incompatible change, then you can simply bump up the major version 2, but you can keep the package name. And that's, in our convention, that would be illegal. So, and that's because the contract for this package is being replaced. So the original contract is in fact being destroyed. And that's why you're not allowed to do this by using the name that you already have. You simply don't do it. Simply don't change anything that you've released as a version 1. Simply don't break it. That's the conclusion. And this is also because there is no way for the system to really cope with this, with the relationship between the new contract, which is incompatible with the old contract. So the proposal is to, yes, then use a new name in a associated with a convention. So embed the version number in your package name. So there is some relationship between these two packages, so you do know that v2, that because you're using the first part of the packages, the path is the same, that you know that this has something to do with this, the new one, but in a technical sense, these packages are independent. And as a further part to the convention, you give it a version number, which is 2.0. So this indicates that it is not sort of something completely original, it is a version 2 of something. And if this convention is upheld, then you would know, okay, this is a new version of what the package name is without this added additional .v2. So it is technically something new, and that's true. So the package name is technically something new, but also the contract is something new. So that's a relationship which is sound, which works. And also the bundle name and the version number, they reflect some continuity. What you could discuss is whether this new package could also go through some prototype phase. So the new package could possibly also start out with a 0 major version number and then jump, instead of jumping to major version number 1, it would jump to major version number 2 immediately from 0 dot something. But the prototype phase is something very open. So this would be probably a little unusual to have prototype phases for a new version, a major new version of something that already exists, but it's conceivable. And whether in the prototype period there could be some semantics added to version number changes behind the 0 dot, yes, but that's not really very useful. So if we go back to our example here, so what happens here is at the breaking change point, at this time we, according to the convention, we don't go from OSGi 1.2 to 2.0, we go to OSGi.v2. And there we introduce this new package name, and this is a non-breaking change, and that means for the module fast, when it wants to proceed beyond OSGi 1.x, it can simply start using OSGi v2 in its code while still referencing OSGi 1.2, if only for the purpose of being able to work together with slow 1.1. So this is the main difference in the whole convention. You can view it as something quite simple, even trivial, but it's quite significant to say that I'm not going to break the meaning of OSGi ever once I've reduced it as, published it as 1.x, and I'm going to introduce a new name when I want to make a breaking change to it. And then the fast-moving consumers can consume both, and the slow-moving, they don't have to worry about this ever, because they never need to upgrade. And this is not unrealistic. It's not unrealistic to have code around that you're using that is not ever going to adapt to some other module that's had a breaking change in it. So that's, at least to us, it's a quite familiar thing. So now you find that the valid configurations suddenly are practically, or there are no invalid configurations anymore. So you can pick from these new fast-moving modules together with the slow-moving ones. So the findings, at least the positive findings, there are also some, I'd say, not so positive findings. The positive ones are that, yes, it's now practical to have breaking changes to introduce brand new stuff. Migration, you don't have to really worry about migration unless the old module has problems that are, because it's not evolving, that have nothing to do with its versioning, but simply with the fact that it's becoming so old that there's things in it like security bugs that are not being fixed or so. That can be a reason that you can't postpone migration. That could happen, but in principle it's possible. It's possible to have very slow or parts of the system that simply stop evolving and parts that are moving very fast. And you can use adapters, so that's also quite powerful, because you can have an adapter that adapts between the old version of the package and the new one. So you could even release an adapter, so you could release yourself a version of OSGi 1.3 that actually has this functionality inside, because you're simply using re-implementing parts of the code to use the new functionality, for example, to make it compatible. And there might even be cases where you have to do this, because you might have cases where such a module is in fact a singleton, sort of like configuration admin or something in OSGi. So you can't really have an old version of that and a new version of that. So you would have, you would want to create provide an adapter that allows these slow modules to use your new singleton without having to ever make a change to their code. But it's possible. It becomes possible because you've not broken anything. Okay, and this doesn't address any all constraint violations that you might find in your code, but it does address this typical user's constraint where you are trying to bring two incompatible versions to connect them to one piece of code. Okay, sort of on the not so positive side, I would say this the convention might look odd to some people. So adding sort of a version component to your package name, for some people this feels strange because we already have a version number in the actual OSGi version number. So that might look odd. It's interesting to know that the Go language guys, they thought hard about this problem as well, and they came up with a similar solution. So they said, yes, and when you go from 1.x to a newer version, you have to introduce this kind of version element into your path. So they have a different way of distinguishing between modules and packages, but you will find that in the module, in the path to the packages, there will be this v2 version element, and it's actually a must. So it's not a convention, but that's part of their rules around modules and module names and package names. And another drawback might be, okay, we have another rule. So we already have some complexity around the versioning model, so why introduce something new? But you could argue that, well, it's going to be simpler because now you're going to never have to worry about version ranges which are more complicated than from 1 to 2 or from 2 to 3 or so on. So it will be, it will make that part robust. But still, it's yet another rule, and you would never find a violation around the upper bound. And as the tooling is now, there will be no one to help you with this. So the tools can't see this continuity yet, so you would have to make sure this convention is somehow recognized by the tools, and they help you with applying the convention and even putting it into the API tooling, for example, to tell you when you want to upgrade to an incompatible version, to suggest help you creating these new package names and applying them. And as long as there's not a hard and fast convention, it could be that humans will not really find the best approaches themselves, so they might have different ways of finding new names or use different conventions, and that might be harder for others to understand what's going on. But in any case, semantic versioning doesn't solve that for you either. So this is not, it is a drawback, but it's not really a drawback of the convention, but of the situation. So to summarize, this is a convention that in the discussions within OSGi is it's been kind of, it's kind of the result of discussions going on in the OSGi expert groups, and there's an endorsement for this idea. So the next step would actually be to evangelize it and make it palatable, probably by providing tooling, by providing support for applying the convention. Okay, so this is it. We could look at code. I'm not sure. We're at the half hour already, right? So.
You got now 5 minutes.
Yeah, so I don't think I'll dig into the code at this point, because I'd rather give you back 5 minutes, and if there are questions, just bring them up, please. Or remarks or comments. Hmm? Yeah.
And the bad thing that language doesn't support the notion of model.
Sorry, the language.
Yeah, the language support is absent.
Mm-hmm.
So I also have currently the project in Eclipse and have all these programs. And what I want to share, I think that there is nothing specific between 0 and 1 and 1 and 2. There is no prototype. Because I released O.4, for example, to my customers. They're already using it, right? I cannot say, hey guys, it was just a prototype, right? Because we're starting to build business. You are releasing once you made first deployment, not in 1.0. Once you made first deployment, this is the release moment. So yes, I suggest to start the version from the very beginning, even though V1, V2, because there is nothing actually different between V1 and V2.
So you would declare this phase 1 as illegal? As illegal?
For symmetry, for tooling,
yeah.
and so on. Because there is nothing different. This is my point.
Okay, so well, the only difference I would see is the expectation. So if the problem is a human expectation, I'm solving problems by applying the convention. In this case, my customers would hopefully not have that expectation. But if you say in fact, they are going to ignore your message with 0 dot something, then yes, I agree with you, then you should avoid it.
Look to the reality, look to the Eclipse incubation process. They're starting to release things with O dot something, but doesn't mean they will break everything, right? So that's already important. It's API, yes, it's raw API. The 0 means raw API.
Yeah. Okay. It's a point I can accept as a sort of, not as a convention, but as a best practice. As a best practice to say, just ignore the prototype phase or be really, really careful. I mean, you have these projects that you also know of that they go to 0.9, 0.99, 0.999. They never dare to go to 1 and they...
We will never 3.14.
Yeah.
Or 4.14.
Yeah.
I think we will never have version 5 because of this.
Yeah. Yeah. Yes. Right. That's sort of the rule. Never break something you've put out. Right. Yeah. Yeah. Yeah.
Any other questions?
The way I see it, with semantic versioning, if you got the major versions, because it's kind of a safeguard that says, okay, so in your dependencies, you say you're pulling version 1, and if you bump major 2 because you want to prevent it from pulling this new version, that it doesn't break, because you're supposed to be breaking. With this way of doing, with acquisition, then is it better to not bump major and keep this in the minor version? Because as in your dependency management, most dependency will still pull version 1, and they might not pull version 2, but you want them to be still compatible.
Right, but then you have the obligation of making sure that these transitions introduce new functionality in a way that doesn't break any of the functionality you've already provided, which is, yeah, that's very welcome if you can do it. But it could be that your initial API was so, the design simply doesn't allow it. Because you do want to add functionality which simply can't be accommodated. It could happen, but yes, that's okay. That's.
Any other questions?
Yes, please.
So there is currently no way to endorse this kind of versioning, kind of tooling like D&D or something like that?
Good point, Ray. It could be. Yeah, it's a proposal to at least to help. BND could be a place where which could help, where you could implement the convention. Mm-hmm.
Okay, so you already discussed with the BND guys about this.
Well, it's not on the roadmap right now, but the BND guys are part of the discussion. That's right. Yeah. Mm-hmm. Good point. Okay.